Right now, I'm going to do two practice problems for balancing redox equations in basic solution. But they're going to be fast because we're just going to focus in on the extra steps that you use to balance in basic solution instead of in acidic solution. These are the steps for balancing a redox equation in basic solution. Most of the steps are the exact same ones that you would use for balancing in acidic solution, except for these three here, which you just use for basic solution. So if you want to balance an acid, you do all of this up to here. If you want to balance in base, you go on and you do these three extra steps. And then of course you always want to do the final check to make sure everything balances, whether or not you're balancing in acid or in base. So here's what we're going to do here. I made two practice problem videos for balancing redox equations in acidic solution. So I showed how to get them right up to here. Now I'm going to take the two equations I used in those videos and work them through these extra steps to balance them in basic solution. Here's our first equation. I showed how to balance it in acidic solution in this video here. So if you want to see how I went from here to here, check out this video. Now, what I want to do is take the equation that's currently balanced in acidic solution and see how we can make some changes to balance it in basic solution. Here's the first step. For each H+, add one OH- to both sides. It's these H+ that are making this equation acidic. And so adding OH- is the first step to getting rid of these H+ and making the solution basic. Okay, so we have 14 H+ here. So I will add 14 OH- to this side. And then it says to add it to both sides. So on the other side here, I also want to add 14 OH-. Okay, add these to both sides. Okay, next step here. Combine H+ and OH- to make H2O. Okay, so this is how we get rid of these H+. H+ and OH- come together to make H2O water. Okay, so I have these 14 OH- here. I have 14 H+ here. I don't have H+ and OH- together on this side of the equation. So what I'm going to do is I'm going to take these and put them together to make water. 14 OH-, 14 H+ are going to give me 14 H2Os, and then just everything else is the same. The only change that I make is pulling these two together to make H2O. Okay, so now I have H2O here, and I also have some H2O over here, which is going to be important to keep in mind as we go on to our next step, which is to subtract H2O from both sides if possible. Okay, think of this kind of just like an algebra problem, all right? We have something that's on both sides of the equation, and so we can subtract it out, okay? I have 7 here and 14 here. So I can do minus 7 H2O on this side, and then minus 7 H2O on this side. Plus 7 minus 7, it's going to cancel this out. And then I'm going to have 14 H2O minus 7 H2O is going to give me a final answer of 7 H2O here. So this is what the equation looks like now that it's balanced in basic solution. And you'll notice that we got rid of these H+. We got rid of these H+ that made the equation acidic, and we've replaced them with OH- that make things basic. So here are the equations balanced in acidic solution and in basic solution. Let's look at what's the same and what's different. Okay, they both have 6I-, Cr2O7 2-. They both have 3I2 and 2Cr3+. So these things are the same. Here's what's different. We have 14 H+ up here, making this solution acidic. But then down here on the other side of the equation, we have 14 OH-. Okay, so it's like the H+ were replaced by OH- and they were put on the other side of the equation. Something that's different too is these 7 H2Os. The 7 water molecules are on the right side of this equation, but they are on the left side of this equation. So those are the key differences. The H pluses get replaced by OH minuses, and they switch over to the other side of the equation. And the waters, the number of the waters doesn't change, but they move over to the other side as well. It's like this crisscross that we get. Now, you can use this pattern to figure out kind of a shortcut for changing equations balanced in acidic solution into equations balanced in basic solution. But I think it's still important to know these extra 3 steps of how we go from an acidic solution equation to a basic solution equation. One, because I think that it's not just good to rely on shortcuts. You want to know how to actually do it, just like for your own mind. And then also your teacher will often ask you to show all your work, so you don't just want to be relying on shortcuts. Because of this, I'm going to do one more example where we take an equation that is already balanced in acidic solution and we balance it in basic solution using these 3 extra steps. And of course, I should say that just after we balance this in basic solution, we then want to be extra sure and do a final check to make sure that the charges and the atoms balance, but I don't really want to worry about that right now. I'm pretty confident about our work here. Here's our second equation. I showed how to balance it in acidic solution in this video here, example 2. Now I'm going to take the final answer that's balanced in acidic solution, balance this in basic solution. First step, we'll get rid of these H pluses by adding OH minus to both sides. We've got 6 H pluses here, so I'm going to add the same number of OH minuses. 6 OH minus here. And a really important thing, you want to remember to do this to both sides, not just to the side with the H pluses. So 6 OH minus here, add 6 OH minus here to the other side. Okay, now I've got those OH minuses on both sides, and we'll go on to the next step, which is when we really get rid of these H pluses, where we combine H pluses and OH minuses to make H2O. So 6 H pluses here, 6 OH minuses here, H plus and OH minus come together to make H2O. So the 6 of these and the 6 of these are going to combine to give me 6 H2O. Everything else in the equation is the same. It's just these 2 things coming together to make H2O. That's how we get rid of these H pluses. And finally now our last step is going to have to do with the H2O here, the water. And it's going to be to subtract H2O from both sides if possible. I got 3 H2O here and 6 H2O here. So just like an algebra equation, I'm going to subtract 3 H2O from this side and 3 H2O from this side. It's always got to be the same on both sides, and I chose 3 H2O because it's the number of H2Os that I have here. So plus 3 minus 3 gives me 0, so this essentially cancels that out. Here, 6 H2O minus 3 H2O is going to give me 3 H2O. Here it is. Here's the final version of this equation. The H2Os are canceled out on this side, and I have 3 H2Os on this side, and this is what the equation looks like when it's balanced in basic solution. I don't have H pluses anymore, which would make it acidic. Now I have OH minuses, which are making it basic. Here's our equation balanced in acidic solution, and here it is balanced in basic solution. What's the same? 3Br2 are in both of them, Br031 minus are in both of them, and 5Br1 minus are in both. What has changed? We've done this crisscross that we did last time. The 3 H2O that were on the left side in the acidic equation are now on the right side in the basic equation here. And the 6 H plus that were on the right in the acidic solution have been replaced by 6 OH minus on the left in the basic solution. So once again, now you know the steps for how to go from an equation balanced in acidic solution to one balanced in basic solution. But you also know this crisscross shortcut that you can use if you're in a pinch. Once again, just in case you want to review them, these are all the steps you take to balance an equation in basic solution. These are all the ones you do for acidic, and then for balancing it in basic solution, you add these 3 extras on the end, and then obviously you just want to do the final check to make sure everything balances.